Hello all, my name is VEERA Surya Chinimilli, and today I'm talking about the project report of recurrent neural networks for sequence data. And my final project is, and first of all, a time series dataset. We explore several data formats in this dataset based on the compute limitation or the nature of the dataset. The selected dataset health animal bites include reports of animal bites, including those from dogs and cats. The period covered by this dataset is May 5, 1985 to June 1, 2010. Rather than using the complete internet dataset, I have chosen a subset of the data. The dataset contains particular information such as the data of the incidents involving animal bites and the species that caused them. It is formatted as .csv file and offers detailed information about every animal such as gender, color, and status of vaccination. Interestingly, it includes a list of names of the animals that were bitten. I have included a link to the Kaggle dataset below for the convenient access. I have only analyzed 500 data points, even though the entire dataset has over 40,000 entries. In this dataset, we have the following columns: byte data, the byte data occurred; species ID dex, the species of animal that bites; breed ID dex, breed if no; gender ID dex, gender of the animal; color, the color of the animal; vaccination underscore VRS, how many years have passed since the vaccination list; vaccination data, the data of the last vaccination; victim zip, the zip code of the victim; advance issue Y&D disk, whether the advice was issued; where bitten ID disk, where on the body of the victim was bitten; quarantine day, whether the animal was quarantined; disposition ID disk, whether the animal was released from quarantine; heat sent data, the data of the animal heads was sent to the lab; release data, the data the animal was released; result ID, result from lab test for rabies. The byte data is represented numerically by the byte data, which is formatted a month, a day, a year, followed by time. Example 5/5/1995. Time is 12 o'clock. And the link I provided the data set link, which is from Kaggle, and you can search as the animal bites. Part 2. RNN, a simple RNN neural networks with sine wave data. Design of the neural networks that has two layers. There is only one hidden vector H in the basic recruitment neural networks of simple RNN. The one-layer neural network is referred to as vector H, since there is one just hidden state vector represented by it. The feedback is present in the single-layer network. In honor of Professor Jeffrey Hellman, it is sometimes known as the vanilla neural networks of LMRNN. The architecture is divided into two components. One is the simple RNN, also referred to as vanilla RNN, and the feed-forward neural networks. A feed-forward neural network consists of fully linked layers. Now, the neural networks will be constructed and trained and tested. While we use this fundamental library because we'll be working with vendors and numbers as well as conducting some data visualization and graphics. To import certain models, we need to use keras, we need to use dance layers, which is basic RNN. The following RNN diagram is as like, which is an input layers, and which includes hidden layers and the output layers. You can see there is more input layers, and we can see only two output layers. Next, the time series generators needs to be built. We will either create a sine wave or make the batteries in order to put them into the model. Keras is a perfect tool of developing, evaluating, and refining the model. We will use the min-max scaler to generate sine waves. The data needs to undergo some preprocessing after it is generated. To do this, we shall normalize the data into the range. We need to import a basic library such as import as panda, import numpy as np, and matplotlib inline, import matplotlib as plt, and we imported the sum of the libraries and the codes from, and TensorFlow from Keras models and generate data from x-axis and y-axis. Firstly, we'll make use of NumPy line space function. There will be 500 values or data point generated using a range of 0 to 50. We ask this function divided 500 into data points. For x, we have 500 values that ranges from 0 to 50. We'll then use the trigonometric functions to find the values. It is an array. Similarly, y is an array. To build the graph with assigned value between -1 and 1 is utilized to add all of the data df to the data frame. In this data frame, we shall have x-axis and y-axis. The genuine data is y-axis and the index is capital X, and the genuine data is capital Y. The index is the first column and the actual data of variable in the second column are the next five values that needed to be printed. It is believed that the index is not true characteristics. Split data, train or test. There are 500 accessible data points. Two data frames need to be created from the original data frame. The starting index is between 0 and 550. Will receive the 500 data points in the data frame. One is meant for training purpose and another for the testing purpose. To pursue the data with n minimax, we had a class named scalar. Use it to fit data frames into trained scales, which we have to train. We generate a time series generated by dividing the range 0 to 50 into 500 data points. The length of the input sequence is divided by the number of time series used to forecast the future. Split data in the form of Python code is as shown in the below report. The time series generates the time series input sequence and the length is equal to 3 for this sequence with all be taken into account. Using the three prior data points will forecast the next one. There must be a clarification of the batch size. When we train or test the sample, we have to fit into a model. A batch is the assembly of test specimens. The specimen one will be predicted using 500 prior data points. In this project, we just consider one value batch size is equal to 1. The following elements needs to be considered before creating an instance: batch size, input datasets, and output datasets. The input datasets will be normalized datasets, and the output datasets will have a length of 50. Python code is given the below to train the datasets. Build and train. The recurrent model must be built. Initially, it is necessary to list the features. The data frames contains a single actual attribute. There is only one thing about us. We will leverage multiple APIs utilizing Keras. In addition to sequential API, we created a model in Keras and named it as a model. Since the layer is empty now, it needs to be added in our one layer vanilla RRM. A feedback network is the second subnetwork. We are going to add simple onion layer to the model. We are going to use 100 neurons to build RNN. With confidence, we can use the 50 history points input sequence in this project. After the layer is formed, we have to shape it. The input has two-dimensional shapes and the length of the input sequence, which is determined by the subsequent step. In the first step, the next layer is fully connected and consists of a single neuron. When we combine the model optimizing must be used. An essential phase in the model processing is specifying the cost of being divided into 500 data points ranging from 0 to 50. Both continuous data points and the floating points value makes the value. For continuous MSC is the date notion cost function algorithm represent an alternative. For these layers that almost 10,000 parameters are produced. One can be found in the second section. Creating a time series generated instance. The Python code is like in the report, and we created these outputs arrays. Train and fit. The method we need a trained model is fit to generator. Keras offers a suitable method. We have to fit it or inject input into the model in batches. We use a time series generator. The time tier generator and epoch parameter will be used. When we train a mode on training datasets divided into small batches, the samples are prepared and the models will be trained over multiple iterations. The model will be injected with a single batch of samples. We finished one epoch turning data after input. Compile model code reflects as this one. We generate epochs. An epoch is one type of that occurs After we have completed training that model, that is the part of the training data sets for this project, we'll train throughout the 5 epochs. The system is trained using the 5 types of batches created from the original data. Evaluating model of test dataset, there must be one sample available. The sample consists of 50 data points. So consists of three dimensions. We need to define an empty list before we can forecast the value. Next, we need to obtain input sequence first batch. The first batch should consist of 50 points. There is only one sample for each batch. There are 50 and 100 data points on the testing data. For each iteration, we'll predict the current batch using the last 50 points. Visualization model after training, and the graph as should reflect this one. And we successfully obtained the graphs, and also we successfully obtained the sine wave graphs from the code. And from part 3, RNN LSTM cells core concepts. Vanishing coordinating problems. When training deep neural networks, especially those are gradient-based learning and backpropagation, the vanish graduating problems arise in these networks. The graduate of the error with respect to the current weight is used to modify the weights of each layer. The gradient should ideally significant enough of the effect on the weight in a significant way. But in deep networks, the gradient tends to get less and smaller as it wrap proports to older layers, particularly when sigmoid and hyperbolic tangents functions are utilized as the actuation functions. The vanishing graduated picture is look like this one. There are two inputs and the one outputs. In between there are three hidden. The gradient magnitude can drop to such extent that the first layer weight hardly ever changes, thus stopping their learning process. As a result, the network capacity to learn and create features or patterns found at early levels of the network is limited because those layers learn either very slowly or not at all. A calculus chain rule is used to determine the gradient of the loss function with regards to the weight in the neural networks. The gradient of the deep neural networks for a weight W in the earlier layer and the product terms for each layer after exploding gradient problems. On the other hand, the opposite circumstance, the exploding gradient problems, occurs when gradients get unnecessarily huge during training phase. This usually occurs in recurrent neural networks. For deep learning networks, the weight may be fluctuate, deviates, and become not a number. In an unstable networks caused by the huge gradients, causing the weights to shift excessively, the networks make coverage up to less than ideal solution as a result of this instability, which frequently prevents the network from reaching a solution. In networks with lengthy sequence or deep structure without appropriate weight initialization or normalization, the exploding gradient problem is increasingly prevalent. Vanishing gradient and exploding gradients. Vanishing gradient is less than 1 and exploding gradient is greater than 1. Conversely, they traverse a large number. The product has become extensively large, leading to the exploding gradient problems. The graph is shown below for exploding gradient and vanishing gradient. Limitations of simple RRN. Difficulties in identifying extent term reliances. Relatively large time intervals between events make it difficult for simple RRNs to learn dependencies between them. The main cause of the vanish gradient problems, which occurs when gradients get small and make it challenging for the model effectively changing its weights during drag proportion through time. Vanishing, exploding, graduating sustainability are previously shown. Simple error and vulnerable gradient issues is exploding or vanishing that are therefore less useful for training lengthy data sequence, limited memory. Simple error can only have written information for the brief period of time because of their limited memory capacity. The restriction result from the fact that they process in sequence using a single hidden layer, which is the basic structure, which makes it unable to capture more interactive patterns in longer sequences. Insufficiency in parallel processing compared to other neural network architectures, RNN are less suited to parallel processing because of their sequential design. Limitations of simple RNN, a gradient issued handled by the LSTM neural networks. LSTM neural networks are a unique type of RNN that has the ability to learn long dependencies that only created expressly to get over the long-term dependency issues dealing with vanishing and exploding graduate and get around simple RNN drawbacks. Solving the issue with vanishing and exploding gradients, the distinct architecture LSTM consists of memory cells and gates. By controlling the information flow, the gates enables a network to store or discard data over extended period of time. By controlling updates and modification to the cell state, the gate helps to mitigate the vanishing and exploding gradient issues. They do this by utilizing the SIP mode and time functions. Recording extends duration dependency, unlike simple RNN, LSTM may retain information over longer sequence because of their gate. In features, they can be used before very effectively in tasks like time series predictions and natural language processing, among other functions. Graph of long-term function is essential. Effective education. Celestine can learn from sequential more effectively because of the selective forgetting and retention abilities, enables them to ignore irrelevant information and concentrate on more pertinent information. Adaptability and versatility. Large data and complicated patterns are challenges that simple alone cannot handle. LSTMs, on the other hand, have shown themselves to be flexible and adaptable for a wide range of challenges across multiple domains. To sum up, LSTMs are the biggest steps in Polaran since they solve important issues on vanishing and exploding gradients and make it possible to analyze dense data sequence. Part 4, LSTM neural networks with time series data. The, there are three input layers. Hidden layers are very high and there is only one output layer. There are several distinct series. The first we need to import some basic libraries matplot to achieve visualizations and out series RNN it will be connected MLP composes several layers. Will utilize time series generated through time series inputs that we need import from keras in order to scale the data. We also need a min-max scaler. We need some data that needs to be sequenced in order to use basic RNN. It belongs to the temporal sequence in this instance. I will be using stock data. The stock data has a wealth of data. It is possible to view that it has 746 forms and 7 attributes. Each quality is changeable. The column is specified as an integer, and minimum, maximum, and standard deviation properties of this statistical summary. And the graph is shown from the code. We generated the graph like this. It has a higher pitch and has a lower pitch, and it goes to higher drop down, and then it will increases will work with a time series will deal with lengthy and historic data points. This is an input 60-point series. It is necessary to separate the set into portions needed for testing training. The dataset contains 766 data points. The length of the data frames currently number of data and number plus the length of the sequence in total. The out we 746 data points. Finding the data points index among the 746 data points that comprise the complete set is the next step. To divide the data set, we need to find the index minus and the length. Testing data 745 was the data points final index. Come. Now the data needs to be standard with range between 0 to 1. We are capable for more. We'll make use of the min-max scalar class and tool. We'll refer for it, put it and normalize the data if we discover a fit. And with the training set, we need to create a time series generator so that we can train the model. The model is usually where the input is fed. However, the batch is also an option. Batch stands for rectification of samples. In this case, a sample of series input sequence plus the batch is composed of 32 samples. The sample consists of a time series input sequence. Visualization model performance after training. The graph shown below from 0 to 100 and y-axis 0 to 0.14. The phase of the project must be specified the number of features. The closing features of the dataset is when the feature refers to the total number of variables of characteristics in the datasets. We will use the LSTM layer in the neural networks construction before utilizing the sample array providing by VEERA. It is also used by LSTM neural networks with a new layer dropout. LSTM fit time series are used. The one time series is used to generate the output. The output will be sent to the layer. After that, the future output will be sent to another layer. For example, you can show the percentage declining if we see 100 and 100 and 1100 and which is usually between 10 and 15. In order to get ready for neural networks, we'll build keras one after the other, and the graph is shown below, which is the blue is the closed one and the orange one is the prediction one. The model makes prediction throughout the training phase. The model history revealed to us who is the latest value of our data frames. We'll watch the model performs training process. While it begins training, we have to confirm the values for the model to be tested. We also, while it being trained, we have to confirm the value for the model to be tested. We have also need the test data. The test data have the batch size of 1 after further adjustment. Each batch set has single input sequence. Test the modality by feeding the time series into the generator. There will be values of 4 parameters. 60 data points are present in the input sequence, and next we will train the data and create a time series from the model to forecast. Since the anticipated value is not normalized, it must be then transferred. In addition, the projected value is normalized before applied 746 test data sets. In this case, testing uses 10% of the data, enhancing the amount of time series data. The data is accessible for testing and training in order to improve the long short-term memory. Technique model accuracy. It is crucial strategy for obtaining more precise result. It is made up of 4 layers. The combines generates and state and output of the cell. After then, these two objects are moved to the next hidden layer. LSTM contains 3 logistics mod gates on one layer compared to our one CAN layer. The LSTM layer has taken into consideration of 50 neurons. Each contains of 30 neurons. The model has 6 layers with a dropout level, and there will be sequential manner. Every layer is interacted. We'll supply additional tool to fit the model. The layer is lowered by 0.01% using the basic RNN neural network. The batches and sequence of data are created to fit the modalities. The batch refers to sample and refraction, and the input sequence consists of 60 characters. In this case, a simple RNN is the time series input sequence. A sample consists of a time series input sequence. Manual constructing batch not a realistic tool. While using the keras, the index of the data set is 60 points. The range of the data point is 1 to 60. This allows one to forecast the value. Index is 61 for time series. We use 100 epochs, while for forecasting 4 epochs. Summary of the core parameter network. Data set is stock price data set. Percentage for data set testing. Percentage is 10%. How many layers are LSTM? 2 layer LSTM. Number of neurons. Each LSTM 25. Any dropout layers? Yes. If the dropout layer percentage is 20 percentage. Length of the time series input sequence is equal to 500. Batch size for training is equal to 32. Batch size for training is equal to 1. Number of epochs for training is equal to 100. Model used LSTM VEERA sequential. The result of being built to train, test, retrain, and forecasting sections were already explained in the above design. Part 5. Redesign the LSTM neural networks to improve performance. New design of the neural network. There is a lot of distinction series. First, we need to import basic library. Matplot is used to achieve visualization. A special dropout series RNN will be used. It is fully connected MLP is composed for several layers while utilizing a time series generator to create the time series input that we need to import from keras. In order to scale the data, we also need a minimax scaler. We need some data that needs to be sequenced. In order to use basic RNN, it belongs to temporal sequence. In this instance, I will be using stock data, the stock data of a wealth of the data, and we import the pandas, and from transport TensorFlow import sequential LSTM dropouts and NC. It is possible to view the data. It has 746 forms and 7 attributes. Every quality is changeable. The volume is specified as an integer. The statistical summary of a Numerical properties include the maximum, minimum, and standard deviation. Will compile trustworthy data and have conducted a one-time series here. If we begin at 0, this should have index of 4. I'll just start before 4. This must be a one-time event. We'll consider the closing price inversion of the dataset. Time series will be visible shown. Nothing less. We'll choose one of them, and then will be closing price. The graph is shown like this, which is a blue is like closed one, axis is from 0 to 700. From 0 to it increases gradually, and the maximum is 34, and it's gradually decreasing, and then after at 22 it will increases and decreases eventually. As we work with the time series to deal with lengthy and historic data points, this input 60 data point series, it is necessary to separate the data into portions intended for testing and training. The dataset contains 320 data points. The length of the data frame, the current number is that the number plus length of the sequence. In total, there are be data finding the data points, indexing among the 842 data points, and compromise the full data set is the next step. To divide the data set, find the index minus the resting data length from the beginning to finish. The data point has an index of 604, and the code of the data is like this one. The total params is 50,851, trainable params is 50,851, non-trainable is 0, and the epochs are we tested the epochs. The test data contains 50 historical data points that are used for prediction. The last for training data records as well the information to records the functions. The model is usually input, however, batching is also option. Batching stands for rectification of samples, and the graph is shown below. Prediction of testing using time series generator. Hmm. The phase of the project must specify the number of features. The closing features of the dataset is 1, and the feature refers to the total number of value characterization in the dataset. We will use the LSTM layer in the neural network construction before utilizing a simple RNN layer provided by Keras. It is also using LSTM neural networks with a new layer. Dropout LSTM fits time series are used. This one is used to generate the output. The output will be sent on the layer. After that, the future output will be sent to another layer. For example, we can show the percentage decline. If we see it 1100, which is usually between 10 and 50, will develop keras in a sequential manner in order to become ready for the neural networks. Creating time series generator for forecasting. Build and compiling fit in LSTL for forecasting. The model fit generator forecast is from we use 40 epochs. The normal fit function will be employed. There will be several void IDs for each step. Put sequence must accommodate 40 batches. We are preparing for 40 steps. During the 40 iterations, we will run 40 batches of the input sequence with a 0.0015 losings in the magnitude. It is necessary to view the model over the course of training of the model. We will discover the history of the model. In the instance length is testing uses 0.2% of the data, boosting the amount of time series that is available, and testing the long-term short-term approach to improve the model accuracy. The model has 6 layers with the dropout layers were built in the sequential mode. The graph shows a level. The forecast graph is in represents orange one, and the closed one represents the blue one. Core parameters are data is stock price market as usual from like the part 4, and we use 40 batches of training. 40 batches for testing is 1. Length of the series time series input sequence is 1, 2, 4, 5, and number of epochs is 70. And compared net performance, the long-term short memory is well-known. Long-term variation recommended. The performance variation of these two networks are compared in the study consideration factors like data sets, quantitative evaluations. The similar scenario where annual stocks market is collected or forecasted for the next month. And instead of employing batch or mini batch trainings, online training will be used to fit the model with a batch size of when it is acceptable to accept some changes in the model fit. As a result, we'll adjust the following parameters in the models. Testing parameters increased 10 to 20%, increased from 20 to neural number of neurons in each LSTM network. If dropout layer is increased from 10 to 20%, batch size is increased 30 to 40%. And the final project report recurring neural networks views of the basic subsequent all of the inputs and outputs conventionally neural net depends on authority is crucial to keep in mind of the previous fourth throw because of the situations necessary like this speculating on the other word that will comes the sentences. And in the conclusion for conclusion we learn about the RRN advantages and advantages and how LSTM differs from the solves limitations of the basic RRN model based on the research of the course. This cell should contain theoretically LSTM with a strong long-term reliances. We also improved the data splitting intersections and testing model depends on how to create LSTM models with several parameters at the same time. And thank you.